Hello, hello. Glad to be here. Glad to have you all here. Um, this is my first time in Florence, or Italy in general. And I mean, there's so many galleries, so many drawings, and I'm here talking about drawing less. Um, all right, so let's start with what the agenda is. So today I'm going to talk about a tool which I built for my team, my department, my company, um, which helps in visualizing the architecture diagram and also helps in debugging if you have any errors, and that automatically refreshes as soon as you make any changes in your architecture or anything in your system. So today we'll be talking about what was the motivation behind building this tool, the approach that we took as a team to build this tool, and how you can do it if you want to do it for your organization, and the walkthrough also, like how you can do it in different steps, and why this tool will be beneficial for you and your organization. And in the end, I'll take a few questions. All right, so a little bit about me. I'm a software engineer at Bloomberg. I work specifically in New York office in the dividend forecasting team. I can talk about like anything related to my team later on if you want, if you have any questions. Um, and before that, I was doing research work and studies between distributed systems and machine learning. Right now, mostly I do finance and application building. All right, so regarding the tool. So what was the motivation? So what happened was last year, especially in COVID, the business grew crazy, and we started hiring a bunch of people. Specifically in my team or in my department, we hired literally like 30 plus people. And because of that, we started onboarding new people and mentoring. So when I started mentoring the new joinees, the newcomers, what I found was that there was a gap. The gap was between, like, we had a lot of, let's say, knowledge, like, hey, this is the software, this is the documentation, this is the tutorials, these are all the things that we have for you to learn about. And it was like pretty sufficient if you take everything together. But then there was a problem. And the problem was that everything was just everywhere. And what I mean by that is that there were multiple diagrams, there was a lot of documentation out there, but let's say but they were all distributed. Some were in form of, let's say, a wiki page, some were on a GitHub page. Everything was just like not organized, and which is something which I've seen in my previous companies and previous wherever I've done internships and work and everything. I was like, this is a common theme. On top of that, I think within my team, we had a bunch of, I would say, the same software or same application or same system. We just had multiple views of the same thing. And which kind of makes sense because some were technical and were for engineers, but some were for, let's say, just manager. They don't care about like which service is calling which service. All they care about is, hey, which product, like, what is the main gist of it? And that is justified, but like, but that is a problem. You have to, if you make any change to anything, you have to update everything out there, which is just like not scalable and not the best way. So, and on top of that, as I said, there was no single point of access to. I had to literally, like, I'm not kidding, I had to give more than 25 links. I like, hey, these are 25 links, go do your homework and come back to me if you have any questions. And I don't think that is the right way or right to approach the problem. And on top of that, once we figured out this was a problem and I started talking to, I would say, the managers, the team leads and everything about it, they were like, yeah, this is something which we also see when we are debugging. Let's say when we have any client issues and considering it's a financial product, we have to act within few minutes. And in that case, we have to debug, like, okay, let's say the service is crashing or something. Like, yeah, we are not able to like pinpoint quickly, but we may be able to do it within time, but we want to be quicker. How can we do that? So like targeting both of them, we thought, hey, can we come up with some solution? So let's identify what the general problem is. In documentation or anything when it comes to visualizing how the system looks like, we like monolithic versus distributed architecture. And on top of that, you don't want to be reminded that, hey, like whatever you've done is out of date when, especially when you need it. You want to know before that. So what an ideal solution would look like. So it should be single source of truth that, hey, I just give you one link, I give you one page, or one place where everything is there. It's not distributed, it is very easy to access, and everything is condensed in one place. On top of that, if anything changes in your system, it can be auto-generated, auto-synced, and auto-refresh. How can we do that? Like, I don't want to be reminded later on that, oh, we did this addition, some engineer made these changes, but we have not reflected this in any of the things. So when, let's say, there is an error, and you're trying to figure out, oh, I didn't know we were dependent on this package, or we were dependent on this databases in some or the other way. And second, I think this is my personal, like when I was bringing, I was like, especially even while I was studying, like why are we drawing still flow charts? Why are these like boxes which are tagged as, oh, this box is a database, this database is talking to this Kafka topic or something? Why can't it be just more immersive? Like we are here hiring UI UX designers out there and everything, and like why can't we make the experience for us as user, as an engineer, just more aversive, more dynamic in nature, and let the diagram speak its mind. So our approach, before we go into the whole stepwise, like let's understand what basic architecture diagram is, or how can you visualize. It's very simple in its form. It's pretty much what components you have and what is the relationship between each component. On top of that, the best relationship that is being done is human. So why don't we add human into the mix? We'll see how we do that. And we'll use, now considering if you've seen the pattern, the components and the relationship between, like if anybody knows what a graph database is, it fits into the problem solution. And we'll use Python for it because, hey, it's a great language and that's why we are here. So little bit intro on people who've just worked with SQL and not worked with graph databases before. So Neo4j, that is just one of the graph database type. Like there are multiple graph databases out there and you can use any of them to solve this problem. It's just we use Neo4j and it just works great. So in short, what graph databases is nothing but node and the relationship between two nodes. All right, so this is me. I have a manager, let's say Dwark, I report, and that is the relationship. I have a colleague in the same team, Kang, and I work with him. It's as simple as that, nothing crazy, okay? Now, how would you define this when it comes to code base? It's very simple. This looks like a big code, but it's pretty much just the definition and the documentation. But it is just one liner to create a node. It is as simple as write a create keyword, use it, name the type of the node. So let's say in the previous case, it was this node is type of people, okay? So let's say we'll call that node type equals to people, and the name of the node would be Yash. And that's it, you're done, you create a node that way. The next step is creating a relationship between two nodes. All you need is the name of the node 1, you need the name of the node 2, and what is the type of the relation? It could be work, it could be managing, anything. And on top of that, you can add a lot of metadata. And what that means is, let's say, when did I create this node? And is this node still active? This is just an example. We'll see that this metadata is what will help us in debugging later, because you'll add so much like properties to each node that will help you figure out what is the architecture, how it looks like, how everything connects, and how we are storing everything in one place. All right, so now that we understood that, okay, graph databases and Python, that makes sense into this whole problem solution, and this metadata logic, once you add that into it, it becomes a one-stop document shop. All right, so I'm gonna give you a UI sneak peek. So like, you can use any UI, you can convert this, you can hook this graph database into like a web API, like you can use, there are a lot of plugins out there in React.js. If you wanna use, you can make, like what you see this, you can make this like a space theme if you want, but there are multiple ways you can visualize this, but I'm just going to use the in-house Neo4j, which the UI that they give. Very simple to understand, nothing crazy. Just to go over what it means is, we are gonna use the query, the power of query in this databases to help us overcome the different views that I was talking about. Based on what query you write, you can actually see, let's say, a 10,000 feet overview or a very detailed diagram that you want. And that can help you figure out, hey, this service is talking to another service and how everything is related to each other. So in general, what this query, let's just talk about this query, right? Match, and let's say this is a component. So all our repositories, like those would be called components. Here, the tool, what we are using is called interactive. We are making a tool, like we've named it interactive, and the name of that is interactive. So it's as simple as give me a component which is named as interactive, and it will show me this, and on top of that, it will show me everything, or all the other nodes which have relationship to this center of attraction, I guess. So in general, what are the steps, right? Step one is spot it. It pretty much is any data out there in the wild that can help you figure out what your system looks like. That is as simple as that. Then you scrape it, you collect it, do whatever you want, just get that data, merge it with your all the other data which is there, then graph it. Like you have to write just those two little steps which I showed the code base, just like graph it up, put it into your Neo4j or any graph databases you're using, and then repeat that for all the data sources which is present out there. Now, I'm gonna let's start with a very simple data, right? Which is common to everyone pretty much out there, GitHub, all right? So in this, everything that you see on GitHub or anywhere in general, that is a data for you. That will help you enrich your debugging tool or your architecture diagram. So let's say for simplicity, we have created this, and it says that, hey, this, whatever is in the README, that is your description of your repository or of your component. And we are going to store that as one of the properties. You can also use things like, hey, when was it last accessed? So let's say here in the screenshot, it shows 2 minutes ago. So you take that, you get that data. There, like here it shows, hey, Kangmin Bey actually edited this. You can actually also get that. So everything that you see here can be scraped and can be used, because that will help you figure out, hey, okay, who made this change? What was it? Who's the point of contact? Everything is relevant, especially when when you're on a time crunch trying to figure out, hey, how this system works. So now that you figured out, let's say this is the this was the repository, interactive, and if you see, we've added some of the properties. You can add more properties. We've added a bunch of properties, but these are something which we are showing here. One is like, what is the last access date? What was it active? One, yes. What is the code source? So like if you see, like this all is actually clickable. Like on the UI, when you go, like once I give you this UI, you have a way to navigate to all the repositories and you have all the links out there. If you have a video tutorial, you can add that into, let's say, your README, and you can create a parser for it. That's what we've done. And if an organization is linked to your repository, you can also have that and like put it in there and say, hey, which team owns this repository? So let's say there's a huge problem at like a parent level, and you see all the dependencies, and you're like, all right, which are the teams I need to notify right now that, hey, things are going wrong, and you see what is your impact. Now you do this for all the components out there, and you make a little graph, okay? It's as simple as writing one query, match, n equals to component, and give me all the components out there. Now, you've figured out all the components, all the services, all the databases, all the Kafka topics, so everything out there, you have it in your system. But now you want to figure out which component is calling which component storing in which databases, and everything. A good example of that, we have distributed trace, and I'm sure like a lot of organizations out there also do. That is one way to figure out like which service is calling which service or which databases are being interacted. And you can use that to figure out, okay, these are the things which are happening. And this is one of the screenshots, like, hey, I'm hitting one Redis server, or which, like, you can figure pretty much everything out in distributed trace. And the ones you cannot figure out, what you can do is you can create a file on your root repository, and the tool itself will go and figure out, hey, what are the relations, and I can put that in. This is useful. Like you might think this is a very simple thing, and like, what is the significance? The significance is pretty huge because I'll talk about it later also. But the idea is you're isolating the responsibility just to the owner of that code base. Now, why is that important? There are, let's say, you work in a team or in a department where there are like 60 people, there are like more than 100 code bases. You don't know what is going on each code base. All you know is the code bases which you worked on or what you've been trained on. So, and if you're trying to create, let's say, some holistic view out of it, and you're like, all right, who is talking exactly, and is this even correct? So you can write this in this file maybe and like tell, okay, for sure, these are the proper relation and these are the proper invocations that are happening. And what is happening with this is you are getting the actual truth and you're isolating the responsibility. You're only responsible for your code base. And what happens with this is if everybody in the team is following and is doing it diligently, then at all the times, your tool will always be updated and it will be refreshed every time you update the file. Now, on top of that, package dependencies. This is a huge use case in our, at least in my team it was, because let's say there is some security issue that was found in some external package that we were dependent on, or the version that we were using. We were like, all right, this is supposed to be not used. All the repositories which are out there, this has a security issue, like just remove it, use some alternative. This has to act immediately. And you have to, like, there is a time limit when you have to do it. And during these times, the first course of action is which are the services or which are the core repositories which are being impacted by this. And once you add this again in your tool, like the tool will take care, it's very easy to figure out with one simple query that, hey, which are all the services which needs to be checked, and you can keep a continuous track of it. Now, we've got the nodes, we've got the relationships, and this is how it looks like. So it starts with, let's say, interactive. It says that, hey, it is being invoked, like it talks to Kafka, like let's say Kafka topic, which is relations, one is of node. Then it talks to the Neo4j database. The Neo4j databases is actually also being talked via graph service, and you get like pretty much the entire relation, how everything looks like. Okay, honestly, you just need to create few scripts, and a very simplistic view can be very easily developed. But the idea is that the way you get data, the parsing, that would take time as you enrich your tool much more later on. Now, let's say the next part is adding the people. So again, I'm just giving an example that is GitHub. You can figure out like, hey, who are the contributors? But that does not mean that they are the only contributors. Let's say your team lead did not directly contributed, but he's also, let's say, responsible for it. So maybe you have an organization database out there which just stores, hey, how does your organization look like? Or who, like, let's say, even if, let's say, some repository is tagged with some organization, what is the, which people consist of them? And you can take all of that and you can make a team. This is a very simplistic view. Let's say this is Bloomberg. This is being managed by Haim. And then these are two teams which are managed by my manager, and I'm part of one of the teams, which is Index. Now, once you have this, now you just need to join this with the previous graph. And how will it look like? So this is a very simplistic view because we are talking just one repository. We are talking just two members of one team. But it is like when it comes to, like when I did just for my own department, it was like more than, I don't know, 10,000 nodes out there. So like once you do all of this, this will help you. And here also, you can figure out like, okay, you only want to see 25 nodes, you just put a limit, and this is how it looks like. Just to go over, this is interactive. Again, you see that, okay, I own this, I'm part of Index, this, and like you can see, and then later on, if I want to, let's say I'm on vacation or I'm right now here at conference and something goes wrong with this tool, who do you contact? Okay, you see that, okay, there's another person out there who's available. And why this is important is specifically because when somebody new comes in specifically, like they're like, who should I talk to? Like I'm starting to work on this tool. Who is my point of contact? Yes, you can ask me, but when, let's say, something is owned by someone else, you don't know who's the proper point of contact. So all of this combines into this one graph. And remember, all of these nodes have their own metadata, have their own information out there. Now, let's talk about the views, which helps you figure out what are the different perspectives. So let's say you want to figure out all the services which are present. So since we had added the metadata, which is like, what is the type of this node? Is it a service? Is it a database? What is it? So you can just like add, hey, give me all the services which are present. Second is you want to find out all the deprecated services. So since we added access date, you can figure out, hey, whatever was not touched more than a year ago, you can just write that query out there and figure out, hey, these are the things which we are not maintaining, or maybe not, like it is not relevant. We should take a check. And okay, this one is, which is highly used from our space, is that, okay, let's say the component is JSON load. I want to figure out all the databases, all the downstream databases it is hitting directly or indirectly. So it is, once you figure out what is the graph query language, it is pretty easy. All you're trying to figure out is find me all the neighbors where the type is equal to databases and is connected to JSON load component in some or the other way. And once you do that, and you just get this graph, it shows that, okay, it talks to Splunk database, it talks to Neo4j database. Now, all of this, why is this beneficial for you? So first is zoom in, zoom out. Pretty much the idea is, since all your data, everything is stored in one place, and you can use the query, you can make multiple different queries out there and make different views. And what you can, and if you're deploying this on your website, you can have different query for each page and have the same system and a different way to visualize that. And everything comes into one place. If you want to show the metadata where it is there, you can also just show it. Also, if you're being very playful with it, if it has some, let's say, video tutorial or whatever, as soon as you hover, it can start playing video and everything. So it's you can create a very fancy tool if you want. Meanwhile, you can also keep it very simple if you don't want too much knickknacks. Second is static versus dynamic. The idea is everything happens automatically. Every time you make a change in the repository, in the system, anywhere, it automatically refreshes. And it is a great user experience because it is also isolating the responsibility. You're only responsible for your own code base, and which is very helpful, specifically when there are different departments within the same company, because there are so many things going around, and you're like, okay, I'm talking to this service. I don't necessarily own the service. There's completely different team which owns this. I don't understand. For me, I'm considering them as black box, and I don't have enough bandwidth to create an architecture diagram for them. So what happens is they create their own, we create our own, everything gets merged into one, and it's amazing. And that also helps later on when we're trying to combine different data from different departments. And you already know that, hey, these are how the components are talking to each other. These are the data that is getting impacted. And that helps a lot in trying to figure out, how is your department doing, how's your company doing, and how the entire system architecture looks like. So just to give an example, so I work specifically in dividend forecasting team, which is we predict what the next dividend would be. So let's say, I don't know, IBM pays dividend next quarter or whatever. And so there's a lot of data that goes into and a lot of data that goes out. We want to figure out, hey, what is that data incoming? What is the data that we are impacting? If anything from that top level does it impact any of the forecast? Does it impact any of our clients? What are the clients that will be impacted if our forecast does not go through correctly? So this all is pretty important when it comes to, this tool would be very important just to try to figure out what is the whole data flow from start till the end. And that is pretty much it. So any questions?
Thank you. Okay. Thank you. I check if there is a slide. Any questions? Of you are okay. Meanwhile, I check.
Thank you. I've got two questions. I ask them at once. Question number one is, have you invented everything on your own, or have you seen some talks or read a book or article about it? And question number two, I missed a step. So you kind of have several components, and how can you guarantee that every component gets into this one single graph? Are they all GitHub repositories, or does every repository need a certain file? Or how do you guarantee that every part of your architecture is included in this diagram?
Yeah. So the first one, yeah, there was no proper inspiration. Like we definitely researched into is there a good way we could represent the architecture diagram in some way or built a debugging tool. We did not, I built everything on my own, and I did not, I would say, directly took inspiration. I definitely researched, is there out of the box something present, but nothing fit into the box for us specifically based on the data that we were dealing with and everything. So to answer your question, first one, yes, it was built by me and a few other engineers in my team. And yeah, for the second one, it will take into consideration all of them. You can do it two ways. One is either you make sure that all the scraping that is happening, that is consistent. See, you do your testing. And when you do testing on a small scale, you do check, is everything happening for those small, let's say, a bunch, for your department. If it works great for your department, it will work for a bunch of departments. So we did a testing, and we made sure for different, I would say, let's say, different repositories of different kinds, is it working correctly? And it was working correctly. And if it was not, we were enhancing things and everything. Is the passing okay? Everything we did, and it works great for us. Also, we also have a bunch of other, metadata in our company, which makes also sense for us that it is easy for us to keep a track because we are already having a database saying that, hey, these are the components which are already there. So we took, I did a check that, okay, these are all the databases, let's say, my team owns. Is that being shown on the graph? So everything was matching, and everything worked as expected.
Okay. Yeah. I read the question on Slido. So it's possible to show how looks like the code for automatic graph creation?
No, we cannot show the code. No, we cannot show the code. It's proprietary.
Okay. And what existing tools, such as RDoc, did you consider before undertaking this effort?
Can you repeat that?
What existing tools, such as RDoc, did you consider before undertaking this effort?
So we started the research 2 years ago on this. That was when we started looking at this problem. And at that point, we did not find any solution which catered towards us. Not that I remember, things might have changed, I don't know. But there might be, but nothing stood out to us which solved the problem.
Okay, thank you. The last question. The last question.
Hi, great talk, thanks. Yeah. And so I have a question regarding more of a process level question. That is, how do you organize a team or a very large team in maintaining this kind of scheme? Because I think you expect every developer working on some specific project to add information inside this graph, because yes, it's automatic, but the nodes you need to add it yourself. So how did you handle this part, at the process level?
Yeah. So at the process level, it was very simple. It was literally everything is automated. So when I say automated, other than this file, nothing has to be maintained by any developer. And what that means is that all you need, there are scrapers out there. There are different data sources, let's say distributed trace, that it has a lot of things that it is stored on our databases and everything. Or if you use distributed trace from like third party, they can also give you the information, like which service is calling which service. Once you have all of that information, that is all automatic. So all you need to do is either run a daily job, or you run a trigger, or you can hook it up as, let's say, as a listener. So all of those things can be easily hooked, and only thing that you want to maintain, let's say for some repositories which are using some coding languages or something that is not being tracked by distributed trace, all you need is this particular file in the root of your repository. That's what we did. That, hey, what are the, for this part, so this is, let's say, this is PyCon, this is the repository name. What are the relations? So it is talking to this database, it is talking to this service. And since this particular repository is being owned by me, I know as a developer who I'm talking to. As soon as I add another dependency, I just update this, like this particular file, and all you need to do is ask everybody in your department. So for me, let's say it is 60 people, everybody is given a tutorial like, hey, this is a new tool, we are going to use this for debugging, please update this whenever you make any changes to your repository. So once you do that, it is just isolating the responsibility. And on top of that, like if, let's say for some languages, you anyways need to, let's say you have a Docker, and in Docker, let's say you tell the type, it is a database, it is you're using some other different type, and once you create a parser also, if you create a smart parser, you can also identify a lot of things from the Docker setup also, that hey, these are the services I'm hitting, or these are the other things which I'm, responsible for.
Okay. Thank you.